Hey, welcome everybody. Everyone, please join me in welcoming Andy for a session on scaling Jamf Pro for high availability.
Hello. So like CJ said, this session is scaling Jamf Pro for HA. Now, I'm not going to focus on things which are in the documentation, things which you can easily find online. This is about stuff we've found over the last 2 years scaling our infrastructure, things that are going to come and bite you if you don't do them right, but that don't seem to be in the documentation. But first off, we're going to start with who is this bloke standing on the stage that we've never heard of, from a company that we've never heard of. You've not heard of us because we're in Europe, and most of you probably aren't. But that's me. I'm head of technical and cloud services. Basically means the buck stops with me if things don't work. For Trams, who are, among other things, a Jamf reseller, integrator, MSP, and hosting provider. So think kind of Jamf Cloud, but not. And that's the point. So the cloud services bit is the bit where we found interesting stuff, scaling Jamf, and the thing I'm going to talk about today. So we are going to cover in various amounts of details. Quick overview of why you might want to scale your Jamf. Some fundamentals of how Jamf Pro works and how scaling an HA works. Jamf Pro Clustering, obviously. That's going to be the core of our scaling. But also things like MySQL replication, failover, distribution point scaling, replication, and failover. And yeah, those things in varying amounts of detail, depending on how much I chat about each one and how much time we have left. So, first of all, what do I know about HA and scaling? Well, like I said, I'm responsible for a cloud infrastructure. That cloud infrastructure has those things that were on the screen just a minute ago. Let's go back. Come on. There we go. So we have about 65,000 devices. This is out of date. So this was when I wrote the session about a month ago. We are bringing in around 1,000 devices a month at the moment, sort of in growth. We process about 8,000 HTTP requests a second. We have an official uptime that is 99 point something %, but the goal in my team is 100% uptime. And we have customers on every continent around the globe. So we have to make sure that that system is up and running. This session, like I say, is based on what we've learned over the last 2.5 years since we launched the system. It's interesting because we're not Jamf. So we run vanilla Jamf Pro. We get the manual installer from Jamf Nation, and we run that in our infrastructure. We change almost nothing. Literally, I think the only thing we change is a logo on the login screen. So we are running vanilla Jamf Pro at scale, and actually we're running about 300 instances of the Jamf Pro web app at the moment. So let's start. Why does availability matter? So there's a couple of things there. Zero-touch deployment. So you hand your user their Mac, and you say, off you go and set that up. That might be they go take it home, they do it at home 9 o'clock at night, or some of our customers, we ship them Macs to their home address, and they open it up, and we don't know what time of day that's going to be. You can't plan your downtime, because people expect to be up and be able to use the new machine. Self-service. People are going to a user-first self-service. We might install the absolute sort of fundamental requirements on your machine, but everything else is in self-service, which means self-service needs to work. Self-service doesn't work when your Jamf doesn't work. You might have users around the globe, so you plan your maintenance window for 10 p.m. UK time or 10 p.m. here. That's going to affect somewhere. That's going to be office hours somewhere around the world. And finally, the users have high expectations. Macs just work. So people want a Mac because it just works. And it doesn't just work if they try and set it up for the first time when you're having a maintenance window, Or you have to email all your users and say, yeah, please don't try and do anything during these hours because we're messing with the system. That's probably been a change in the last, year or two, I would imagine, where Jamf started being an IT tool. So if it was down for a period of time, just let the IT people know, don't log into the web interface, don't make any changes. Now it's a very much user-facing tool, because even though they might not know it, they're interacting with it at lots of stages in their sort of device life cycle, if you like. So let's get into some details. This is some things that will help you when you are scaling. The database is important. It's really, really important. Everything else is basically just a web app. You don't really have to worry about that. The database, you want to back up, you want to replicate, you want to do all these things too, but everything else you can rebuild. If you take a fresh, vanilla Jamf server and you point it at your old database, suddenly you're back. That's really handy when you're doing scaling and HA stuff, because then you just say, well, this stuff over here I don't care about. I'll scale it up, I'll scale it down, I'll kill it, I'll spin up new stuff. Database, backup, treat really important. So you probably all know this already, but just a quick, how does Jamf actually work? So client talks to Tomcat, so that's going to be your Jamf URL on port 8443 or 443, depending on whether you're lazy like me and don't like typing the 8443 on the end and change it. Tomcat takes that request and gives it to the Jamf web app. The Jamf web app does some stuff to it that almost always results in either reading or writing to the database. And that database is where everything lives. All your Jamf settings, all your policies, all your preferences, everything. It's all in the database. The database is really important. The rest of it, not so much, like I said. And once you get to that, you can start having some fun with things. So what do I mean when I sort of talk about HA? I'm basically talking about designing stuff for failure. So assuming that every single thing in your infrastructure that Jamf relies on will fail at some point, and making sure that when that fails, it has no impact on the users who are trying to use Jamf. My advice on that is automate as much as possible. So, for example, it is all well and good to have multiple Jamf servers and get an alert when a Jamf server fails. Ideally, what you want to happen then is something to happen to make that unfail. Because I'll give you an example. So I was here Monday night, and we had the Jamf welcome reception. And I was there about 6 o'clock in the evening, so that's, midnight in the UK. And I got 3 emails come through to my phone. One email said one of the hosts that hosts our Jamf was down. The next email said some customer instances were unavailable. And the next email said they'd been killed and respawned automatically. So we know what's happening, but at no point did anyone have to go to that system and go, oh, that server's dead, let's spin up a new one and restore the stuff. Because otherwise that would have waited till someone got into the office the next morning and gone, ooh, that's bad. Having one server fail for us is not a problem, because if it had failed, no one would notice because we have multiple of them. We'll talk about that later. But it increases the risk of, if one fails, then another one fails, when the time you're trying to fix it, and another one fails. When we have 3 by default, if all 3 fail, then we're starting taking down that SLA, we're not getting the user experience, blah, blah, blah. So automate, 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 automate more, keep going. Most of the work I'm doing at the moment, and the stuff that I'm tweaking, is not Jamf related, it's not even load balancer related, it's automation related. Making sure that things get fixed, set up, and provisioned as easily as possible. And then monitor everything. You want to know what's happened on your infrastructure, but ideally don't rely on that monitoring to tell you that things are broken and assume that then someone will fix them. Because 9 times out of 10, that someone will have to be you. Even if you have a whole team of people in that monitoring, 9 times out of 10, the person set it up will be the person who has to fix it, because people just go, oh yeah, that's a monitoring email saying the server's down. That's Andy looks after that. It's fine. Which is, not ideal. So let's get the system to do stuff for us. So a little bit about clustering. Now, this session has very little Jamf stuff in it, because most of the scaling is back-end infrastructure. But this is really important. If you're going to have more than one Jamf web app, which you are if you're doing any sort of HA stuff or scaling, you're going to have more than one web app or more than one server, because, HA, you have to turn on clustering. That is effectively what tells the database to expect multiple servers to be writing to it. And then on this page, you must designate a master node. Now, this sounds a bit strange, but that master node must exist. Now, obviously, when you designate it, it exists. But if you get to the point, like the example I gave of Monday, where your system is respawning instances, that master node might have been the one that failed, and the new one will come up with a different IP address, and then Jamf will remember that you've set the master to be this IP here, so the one ending in 93, even if it doesn't exist anymore. The problem with that is weird stuff starts to happen, because the master node is responsible for your sync with Apple Business Manager or Apple School Manager for apps and books. It's responsible for the sync with the automated MDM enrollment. It's also responsible for the APNS queue. So if you send out a command and your Jamf instance can't send it immediately to the device, for some reason it's offline or it's not accessible, it goes in a queue, and that queue sits on the master. So if your master node doesn't exist, none of that stuff happens, which then means you see interesting stuff happen. And anytime we see interesting stuff happen, this is where our help desk are told to go. Make sure that thing exists. And the way you can tell it exists, I don't know if you can see it on the screen, but down the right-hand side, it shows you the number of connections. That is a number of connections that that node is currently dealing with. It will say 0 if it doesn't exist, because it doesn't exist. And all you have to do is edit this page and set it to be correct. But that will trip you up. I can almost guarantee it, because it did us the first time we saw it. And a customer said, APNS doesn't work all of the time. Most of the time it does, but sometimes it's a bit weird. That's where weird comes from. Right. So if you have Jamf on-premise at the moment, and let's say you've left it sort of similar to how it was set up during your jumpstart, it probably looks something like that. So you've got MySQL, Tomcat, and the Jamf web app running on a single server. Might be a physical server, might be a virtual server, but that's what it looks like. That's not ideal for scaling, because we want to scale those two things separately. The way we deal with scaling an HA for MySQL is different from the way we're dealing for scaling an HA with Tomcat Jamf. So the first thing you want to do is you will want to split the database and the web app. And that is much simpler than it sounds. So you take your database, back it up, provision a new MySQL server, restore your database. Beware that in the default setup for MySQL, it doesn't allow connections from other hosts. So make sure it's listening on an actual IP address that can get connections. And make sure that your user account can connect from another host, because by default, when you create it following the instructions, it's a localhost user account, and obviously not localhost anymore. So you split that up, you go and you edit your WebINF XML, database XML, and you change the field that says server name to be the server name or IP address. On that point, DNS is your friend. When we talk some more about MySQL replication and failover later, DNS is definitely your friend. You don't want to specify in there the IP address of a MySQL server, because if that fails, you ideally want some way of pointing that traffic at a replica. We'll talk more about that later, but DNS is great for that, because you can update DNS records and things go other places. Back up the database. Database is important. Don't worry about the web app. There is nothing in there that you can't rebuild. Download the installer, get the manual installer, create some database XML, and connect to the database, and you're done. You do not need to back up web app servers. Then you can scale. You can add as many web app servers as you want. You might do this for HA purposes. So, for example, in our live infrastructure, we have at least one server in each of 3 data centers that we operate, so that if a data center falls off the internet for some reason, things still keep working. You might have them on different VMs, on different hosts, etc. As soon as we start talking about this to customers who've got on-premise stuff, they start things like, oh, well, can we put a web app in the UK and a web app in the US and a web app in Asia? And the answer to that is, yeah, you can, but don't. That's a really, really bad idea. The thing you have to remember about Jamf is that the traffic that's going back and forth to the web app, one is HTTP, so it's designed to deal with slow internet links, it's designed to deal with latency, it's designed to deal with all that rubbish. But also, the amount of traffic going back and forward over that link is pretty minimal. So the biggest traffic going over that is probably when you submit an inventory. And that's going to be a couple of 100 kilobytes, maybe, going up in your inventory. I mean, there's a command you can use on the command line. When you run the sudo jamf recon, there's a show traffic or show connection statistics that you can run that actually shows you all the data that's going back and forward. That's minimal, so it doesn't matter. Put that somewhere, but make sure it's as close to the database as possible, because the link between the web app and the database is not tolerant of latency, slow links, things like that. So better to have the web apps close to the database than web apps close to your end users. Distribution points are completely different, but we'll come to that later. Another thing that we found with this, which is strange, is we found that Tomcat Jamf scales out much better than it scales up. So when we started taking lots of requests, we thought, okay, well, let's make the servers bigger. Let's have 16 gigs of RAM in our Tomcat server and give Tomcat all of it. And that doesn't really give you the performance gains that you would expect. But if you create 16 VMs with 1 gig of RAM and run Tomcat in all of them, you get massively bigger performance. So scale out, don't scale up. I don't know why. I mean, I assume it's because Tomcat can deal with more HTTP connections because there's multiple instances. It can deal with more database connections. But I know it works because that's what we do. We actually use Docker for all of this stuff. So we have every single Jamf instance is multiple Docker containers, and then we can scale them up. That means you've got as little as possible using the memory. What you have to remember is Tomcat is Java, and Java loves RAM. So give it as much of the system RAM as you can, and try and get as much stuff that's going to use it out of the way as possible. Right, so once you've got that, you need some way of load balancing your traffic across those instances, which is why we have load balancers. And the first thing on there is technically not a load balancer. But you could, in theory, load balance traffic across your multiple Jamf instances using DNS. So you have multiple DNS entries, and then when it does DNS query, it gets a random result and goes to that server. That's not ideal. Basically, if a server fails, it's still going to send occasional traffic to it. Not great. Then you've got sort of layer 3, layer 4, layer 7 load balancers. If you are looking at this and you're going to load balance traffic, you want one of those two. They both support SSL termination at the load balancer. So the connection comes in on HTTPS on 8443 or 443. The load balancer deals with all the certificates and the encryption, and then sends just standard HTTP traffic to the Tomcats. What we found there is you get about a 30% performance increase when those Tomcat servers aren't having to do SSL. Layer 4 load balancer can do SSL, but not much else. That's just going to SSL terminate and forward on to all your instances. Layer 7 is what they call application load balancers, and we use those. And we use those because you can actually make traffic routing decisions based on the traffic that's coming in. So I'll give you an example. You make heavy use of the API. So what you might do is you might send your API traffic to a different set of servers than you use for providing the web app to your admins. Or you might send machine check-in stuff to a separate set of web apps than the web app used for admin. Because you might have seen if lots of machines are checking in, doing lots of stuff, accessing the admin console can be quite slow. So you can do that kind of stuff. And like I say, they're application load balancers. If you are sort of provisioning in a cloud, then that's pretty much what you'll get. If you are doing this on-premise with hardware load balancers, then usually it's just an amount of money you pay to the same people to get some extra functionality on the box. Couple of things that you need to bear in mind when you're using load balancers. You need to use a thing called x forwarded for. That basically takes the IP address of the client that's connecting and forwards it on to Jamf. Because otherwise, what you'll find is the IP addresses of all your clients appear to be the internal IP address of your load balancer and not their IP address. And that can get interesting if you're doing things like setting rules based on network locations or IP subnets and blah, 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 blah. You need to enable sticky sessions. That means that when you open the web app and you log in, your session will stay on that back-end server. Because if it doesn't, every time you click on a link, you could hit a different server, and that server won't know that you've logged in. So every time you press on a link, you get logged out. There's various ways you can do that, but the best way that we've found is that when you log in to Jamf, it creates a cookie on your machine, effectively, called JSessionID. That is your authenticated session with the Jamf web app with Tomcat. And that expires in, I think, 30 minutes by default. So it makes sense to use that as your sticky session. So if that is valid, then you stick to that server. If it's not valid, then you go somewhere else. And I've already mentioned SSL termination. It makes life much easier if you terminate SSL on a load balancer. Also, it gives you much more performance. It also means you can do funky stuff like scaling up and down, and it makes auto-provisioning easier because you don't have to load in SSL certs and keys and all sorts of nonsense like that. One thing with this is remember the URL. The URL always has to be the same. So if you have myjamf.company.com, that's where clients will go. You need to make sure that that goes where you want it to go. You can't have myjamf1, myjamf2, myjamf3. That just won't work. You've got one URL. And that should terminate on your load balancers, because then you can deal with crazy things behind it. So if you're doing your SSL termination at load balancer pretty much as it sounds, client connects to the load balancer does SSL-y things to it, and then it forwards that traffic on over non-HTTPS. And obviously, next client comes in, goes to the next node, because it load balances the traffic. Lots of people look at this and say, ooh, that traffic between the load balancer and the Tomcat, it's not secure. Well, it's not over HTTPS, but it's on your local network. You would hope that your local network is secure enough to take that traffic. I would hope, certainly. But if it's not, you could do SSL everywhere. But to be honest, that's a waste of resource. Might not matter if you have a few thousand devices, but when you start scaling up, waste of resource costs money. Especially if you're in the cloud like we are, and there's a bill that comes from Amazon at the end of every month. You can see any waste of resource in that bill, which is interesting. Right, continue on from that. You've probably seen that, I think one of the 10 releases, it might have even have been the first 10 release, started saying, we recommend that you implement a thing called Memcached, Memcached, however you want to pronounce it. It's recommended, but not yet required, and actually that's been the case for a while. What that is an in-memory cache. So it's designed to reduce the load on the database. So things can ask the cache for data before they go and hit the database. Now, at the moment, not a great deal of things are cached in there. I had a look on our Memcached cluster before I came out, and we've got about 1,600 objects in the cluster from about 120 different Jamf instances. So that's 10 to 15 objects each, but that number of objects is going up every time. Although you can run Memcache on your Tomcat servers, you really should run it separately. With VMs and stuff like that, these are not going to be physical hosts, they're going to be virtual machines. So have a Memcache, and don't just have one, because we're doing HA, have multiple. You just specify the list of them, in fact, in that file there. You specify them in the list, and Jamf will use all of them. Specify the same ones on all of your nodes, and it'll just use that for caching. Do not worry about backing up that Memcached cluster. It's just a cache of things in the database. If you need to, you kill it, set up a new one, and it starts caching stuff from the database again. So you don't need to worry about sort of DR for that kind of thing. If you want information about setting up Memcache, great article there from Jamf on how to set up Memcache on Linux. So I'm not going to go into that. Step by step, follow it, works really well. What about upgrades? So I would imagine you've all done an upgrade of a single server, and you probably download the Jamf Pro installer, run the Jamf Pro installer, let it do its thing, and then off you go. The upgrade process for a clustered environment is similar, with the caveat that obviously you have multiple nodes. You need to stop them first. You need to stop everything that's writing to the database before you make any big changes to it. Otherwise, you're going to have some interesting times ahead. And IT people don't like interesting. Upgrade the master node first. That's the one way back in that screenshot at the beginning where we said this is the master node. That needs to be done first. Then you upgrade all the slave nodes, and then you restart them as you're upgrading them. That's the process. Or they're just web apps. Trash them and rebuild them. So we don't actually do any upgrades at all of Jamf. Like I say, we're in Docker. So imagine a standard customer has 3 instances of Jamf Pro running in 3 Docker containers. We just trash those containers. Say they're 10.7, like we did yesterday morning. We trashed 10.7 container. We spun up 3 10.8 containers, and they updated the database, and that's done. It's just a web app. You don't need to do in-place upgrades. You can just trash and rebuild. If you've got a process in place where you've got, this is my automated build, and if you want to talk about automated builds of Jamf and things like that, find me afterwards. I couldn't put it in here because, well, I'm 30 minutes in already. Might do another one next year about Docker and Jamf, but there we go. Find me later and we can talk about that. But yeah, it's just a web app. You can do whatever you want with it. If you don't follow this process, or even if you do sometimes, you will see this error. And that's because you've tried to upgrade the database using a node that's not the master. So you've tried to run the database update from a child node. Now, if you're doing the trash and rebuild, that's because you've probably trashed your master node, and it doesn't think that was master. So what you have to do in that process is you have to turn off clustering before you do your upgrade. And that's just a flag in the database. Like there's a table GSS cluster settings, and you set clustering to 0 and it's off. Or just if you're doing standard stuff, do your master first. This is just to stop multiple servers trying to do the upgrade at the same time, because in V9 you could do that. You didn't get this message. And if you started up 3 nodes all trying to do database updates, that got interesting. Well, it got corrupted is what happened, but yeah. Make sure you have a database before you do this. Automate your updates. So if you're using the Jamf Pro installer, that's got a nice process where it will back up your database, copy out the files to connect to your database, to connect to Memcached, do your upgrade, put it back in. If you're doing stuff in Docker, then just write script to do it yourself. Automating stuff is one of those things that really helps when you're doing HA because it reduces the amount of errors, human error that goes into doing the upgrade. Because you won't forget something because it's in your script. And make sure you test your scripts. So, moving on, out of Jamf. MySQL replication and failover. There's only a few things here. First thing, Jamf Pro does not support MySQL clustering. Don't waste your time investigating MySQL clustering, setting up clusters, and then finding out that it doesn't work. Been there, it's not worth your time. What you want really is master-slave replication. So you have your master database, and that's where all the stuff's being written to by Jamf, and it's being immediately replicated to a slave database. Because then you've got a database over to the side somewhere that when your master fails, you can promote to being live. I'm not going to talk about that because there's a MySQL article there on how you set up replication. And even better than that, the guys at GitHub, so github.com/GitHub, because it's their internal team, have wrote a thing called Orchestrator, and that deals with managing MySQL failover. So if you have multiple MySQL servers, which you will have because you're doing HA, then this will find the server that has the most recent copy of the transactions that have happened on the master, and will promote it to be the master server and do your DNS stuff so that your stuff's going there. This used to be interesting because you had to manually convert your databases to InnoDB for this to work properly. And then every time you did a Jamf upgrade, you had to convert the new tables that created to InnoDB because it wasn't the default. It is now the default. So any new tables that get created by Jamf since, I think, 10.6 are InnoDB, but it will not automatically convert your database. So if you upgrade, it's not going to convert your database to InnoDB. There is a Jamf command line tool that does that job for you. If you do a new installation, then it's InnoDB from the beginning. But just bear that in mind. If you want to upgrade, then the Jamf command line tool will do it. You can see in the Jamf Pro summary how many tables in your database are MyISAM and how many are InnoDB. Slightly off topic, but I had an interesting conversation in MacAdmin Slack yesterday about loads of people don't know what useful stuff's in the Jamf Pro summary. Like things like database size, database backend config, all that kind of stuff. Even what character set's being used, it's all in the summary. It's great. And that's all I'm going to say about MySQL. Distribution point, replication, failover. We'll start with failover. That used to be, again, pretty challenging to set up, should we say? And then this tick box appeared. So if you have multiple distribution points, you can set one to be the failover. So system will try its default distribution point and go, well, can't connect to it or that file's not there. It will then fail over to the one you've put in the failover dropdown. If they happen to both be on the same site, so you're not like saying, okay, hit this distribution point, but then if it fails, hit the one that's somewhere else. If you happen to have multiple servers, then you can enable randomized load sharing. One of the things I dislike about HA is when you have to have something that's kind of a second copy over here, not doing anything unless that thing fails, because that's a waste of resources. So if you can sort of load share across them when they're both working and then fail over when they're not, then that's great. You need to keep your distribution points in sync. So when you upload something to your master distribution point, you need to sync it out to all your other distribution points using Jamf Admin maybe, or rsync, which is what Jamf Admin's doing in the background. Or if you're on Windows, you can do robocopy and things like that. Just get the data somehow into your distribution points and make sure you get it there. Like I said, randomized load sharing for file share distribution points is great. If you're using file share distribution points, make sure you have HTTP enabled. So if you're on Windows, put IIS on the box and have it reshare that over HTTP. If you're on Linux, then you can use any web server. We use Nginx because it's quite good at things like that. HTTP does resumable downloads, which is really handy. Stops your distribution points being hit so much. Likewise, if you have a cloud distribution point, use a content delivery network, because that's going to get data out as fast as possible. It also taking away a bit of the load, and also if things fail, they might already exist in the cache. If you're worried about HA, cloud distribution points are great, because what you're basically saying is, hello, cloud provider, have this stuff, and then you're responsible for making sure it's always available to me. I don't have that burden anymore. Oddly enough, we've found that we're on Amazon. We use Amazon's CDN, which is called CloudFront. It actually costs less money to distribute things via their CDN than directly from a host on their network. I have no idea why, but it does. So you get better performance, you get more functionality, and it costs less money, which is interesting. And they have a feature where you can point at a server on your infrastructure as well. So you can point the CDN at an HTTP endpoint in your infrastructure, and it will just do stuff, which is awesome. And I wasn't sure we'd have time for this, but we have 5 minutes. So anyone got any questions?
For a Tomcat node, how many resources do you give it? How much memory, how much CPU?
So our Tomcat nodes run in Docker, like I say. So we don't give it CPU resources. We give each Tomcat node a gig of RAM. We give each Tomcat node a gig and a half of RAM, and we give Tomcat in each node a gig of RAM.
Oh, really? That's it?
Yeah, because scale out, not up.
Wow.
So if a customer has a lot of devices and it's quite slow, we will add more nodes. We won't put more memory in a node because you get better performance.
Do you find that scales up even with tens of thousands of devices?
Yep. In fact, it scales better that way. Because
Right.
we had 2 infrastructures in V9, Jamf V9, we had big Tomcat servers. And when we went to V10, we went to many small Tomcat servers. And it seems to work really well. I can only assume, like I said earlier, it's because of the other connection engines, HTTP, MySQL, etc., being better. And also Java probably is managing its RAM a bit better because it doesn't have all of the RAM in the world to just eat up and play with.
So on the MySQL side, do you just up the number of max connections pretty high?
Yeah, so on the MySQL node, then we use a formula for max connections, which is the amount of RAM the server has divided by 1.8, I think it is. But basically, you need the number of connections for all of your instances plus 1. We have our nodes set to be used between 1 and 25 MySQL connections, which seems to work really well. But you will hammer your database servers, make sure they're beefy database servers. Every single version of Jamf since version 10 has done more database stuff.
Huh, all right. And you said the max connections in your database.xml are 25 usually?
So in the database XML and the Jamf, we use between 1 and 25. Lots of trial and error, we found that quite well. Obviously on your MySQL server, just make sure you've got enough so things don't not connect.
Great, thanks.
So during the upgrade process, you were mentioning that you basically can do the wipe and reinstall for some of the web heads, but as far as the database I was concerned, is there any downtime that your servers experience as a result of an upgrade to the database?
A Jamf upgrade changing the database?
Yes, yes.
The only downtime is the amount of time it takes Tomcat to start the Jamf instance and the Jamf instance to go through that progress bar. So minutes, I think upgrades take us about 5 minutes at the moment.
Okay.
You will see, for example, if you go from 9 to 10, that upgrade takes a bit longer. I'm told by our support guys who started doing some 10.8 upgrades yesterday that the 10.8 upgrade process takes a little bit longer than that, but we're talking a few minutes longer.
And also you had mentioned that you could take your CDN server and point it to another server and do stuff. What did you mean by that?
Yes, stuff. Well, CDN stuff, caching, basically. So when we originally did this, we had to basically build our own CDN because the one that was in AWS only supported talking to Amazon S3, which we didn't use because of reasons that I won't go into. But they've changed it recently so that you can point it at any HTTPS endpoint, and it will start caching around the globe the content for that. It doesn't pre-warm those caches, but if a user goes over, say, to the UK from here, the first user who hits the CDN, it will start caching content in that location.
I see. And is that your master as well?
The master always has to be a proper distribution point. So either something in S3 or a file share distribution point. So our master is a file share distribution point, which has HTTPS enabled, which is what the CDN points at.
Okay, great, thank you.
You can mark the CDN as master, but then Jamf admin won't work because it can't upload stuff.
And you talked a lot about, or a little bit about monitoring. What is it you use to do your monitoring? What would you recommend?
We've written some stuff ourselves to do it. What I would say to that is that Jamf provide a really good URL, which is called healthcheck.html with a capital C. If you call that, if it responds, then you know that the instance is up. If it responds with empty square brackets, then you know the instance is up and everything's good. Otherwise, it will respond with an error telling you what's wrong. So we use that URL in our monitoring system, and we use one based on Nagios to check that every so often. But that's a really handy URL because it checks all the things you want to know. Is Tomcat running? Can I get to a Jamf instance? Is a Jamf instance actually serving connections?
And that URL again is?
Is /healthcheck, so lowercase h, capital C.html. And yeah, it's a Jamf one that's really good.
Okay, great, thank you.
Oh.
This is more of a two-parter for MySQL. Is it possible to do a hot for MySQL? And if not,
it is possible to do multi-master replication. I would not recommend it.
okay.
We tried it. It's great until it stops working, which is then when we went digging. And like I say, there's a great tool from GitHub that does the job of promoting those replicas, which means you can have multiple replicas of read, and it will promote the best one each time.
Gotcha. So for that master-slave setup, how much manual intervention is needed when the master goes down to say, okay, now promote?
If you just use the MySQL docs, then that is a manual process. If you use Orchestrator, the GitHub tool, that's what it does. It monitors the master, and when it goes down, it picks the best slave to promote it. And that's why I said use DNS in your database XML, because part of that process, it can update the IP in DNS that it's now pointing to for the master.
On your little 1 gig Tomcat nodes, what's the maximum of connections you're expecting on those concurrently?
I don't know.
That they can support?
I don't know is the answer to that. We don't monitor connections. What we do is we pull that health check URL once every 5 minutes. And if it takes more than 2 seconds to come back, we assume that it's busy and we spin up more nodes. The only I could check, but I don't know off the top of my head. I know we're processing about 8,000 connections a second across about 300 Tomcat nodes. So average of that is maths. And yeah.
All right, thanks.
Anyone else? Cool.
All right, guys, that looks like that's going to do it. Let's get another round of applause here for Andy.